another edition of 3D Printing News Unpeeled, brought to you by 3dprint.com. And today we're going to be talking about a couple of things. First is Livermore National Laboratory is telling us a little bit more about the microwave volumetric additive manufacturing technology they've developed. Essentially, it's like a lot of these other volumetric technologies, but they use microwaves to cure models. Now, that they've made a paper, additive manufacturing letters called Towards Microwave Volumetric Additive Manufacturing, Generation of a Computational Multiphysics Model for Localized Curing. So that paper kind of explains what they did. They used a multiphysics model to figure out how the microwave would work, with what resonance would it work best, with what resonance wouldn't it work, and they kind of went from there. So they think that, they've kind of then, based on that, they've kind of proven it out with real resins. And I think it's really kind of useful for loaded resins, like resins that are opaque, resins that have a lot of loading in it, a lot of doping in them, like, for example, ceramics or metals or other things like that. They think maybe you can use this for aerospace, automotive, nuclear, that kind of thing. And for epoxies, and in particular, they're kind of leading towards ceramics, where ceramics are difficult to make. They're difficult to make with a lot of processes. Intricate ceramic shapes have a lot of very new and exciting properties, especially for really high-end stuff that Lawrence Livermore is interested in. They could be used in space. They could be used for arrays and antennas and circuits and all sorts of other kind of materials. And there isn't a lot going on in ceramics, essentially, but ceramics are often needed because they continue to work where a lot of other materials don't work anymore. So they think of maybe it can be used for sensors, or in one process make like conductive, partially conductive parts. And they think that now they're curing these parts in 2.5 minutes, but they think they could cure models in like 6 seconds using like a 1 kilowatt microwave. And that could be interesting for a number of reasons. One is that with just using light to cure parts, you often have a problem that if it's not exposed to light, if it's on a tray or something like that, or even if it isn't, or if you turn it or something like that, you often don't know if the part has been cured properly. And I think maybe with a microwave, you could cure it in such a way that you could be 100% sure, or really very, very sure that you cured it properly using that microwave. So that could be something that, if you want to automate this process, if you want to do something with doing this on the machine or in the build chamber itself or something like that, or making it really a very high volume process, that could be something that you could exploit. They think now that they're printing feature size a few millimeters to 20 millimeters. They could maybe make things about 1 meter in size. And there's MVAM technology, MVAM, I don't know, has some drawbacks. They're saying like microwave systems are expensive, commercial microwave systems. I would add there that there may be some safety aspects here that could not be awesome, and also that there's a lack of microwave engineers and a lot of people working in this field. There's, it's like mechanical engineers. We have comparatively a lot of people that could work on the 3D printing technology to develop it. Here you have very few people that really would have the expertise to push this forward. So this might retard this technology. Nonetheless, this is a new approach. I like the fact that it could do new epoxy chemistries, or maybe even beyond epoxies. I like the fact it could do more new slurry type chemistries, and maybe get us some more performance in some really key ceramic areas where, there's a lot of, because ceramics are so high value and they're high performance and they're difficult to machine using traditional technologies. Overall, the application plus 3D printing plus ceramics is a really good combination. There's some really profitable high volume stuff that really makes sense for everybody. So that's really, really, really good, I think. And the next thing is Orlando Eli. And he has made, he won the Innovate UK's Young Innovators Award, which is wonderful. And he made a thing called Blossom. And Blossom is a therapy tool. It's made for stroke rehabilitation. It's meant to improve your fine motor skills. Now, the thing I love most about this thing is that it looks friendly. It looks engaging. It doesn't look medical, right? It makes me curious. It makes me wonder, what is this? It makes me kind of want to touch it and engage with it and do stuff with it, rather than it looks like kind of like a therapeutic device. It's a therapeutic device that doesn't look like a therapeutic device. And I really think the potential to redesign and humanize a lot of this medical and medical adjacent type devices is a huge opportunity for additive manufacturing. To just take the best of design and to take the best of our technology and make perhaps even very low volume devices that could be very engaging and very, very fun even to work with. You don't want to have a flashback to your emergency room experience. After having had a stroke while doing your rehabilitation, you want something playful, something that is sparks your curiosity. So I really, really like how approachable this is. Um, the flowers are arranged in a certain way. There's three different difficulty grades, and you can arrange the flowers and the little stamen thingies. And basically, through doing that, through that playful interaction, you're testing 16 different pinch grasping type of maneuvers. And so, what they say is that it's meant to be creative as well. It's meant to reconnect you with nature, which I'm a bit skeptical about. And it's meant to just improve your cognitive and motor skills. What is also great about this is they chose PBF for this, and the reason they chose powder bed fusion was the texture. And we don't really talk about texture a lot, but the haptics and the texture are so important. This really underscores that if you have PBF parts, they really are quite luxurious or quite interesting texturally. And we don't really talk about this enough, but work like from companies like Dimension and other companies is allowing you to play with these textures and create these textures a certain way to get certain experiences and to get certain haptics and a certain feel that then kind of responds with or urges you to make a certain interaction with an object. I think that's something we should do much more with. And I really think this is a great thing, a really, really wonderful thing. I think this could be a market for people. This could be something that a lot more people do. Another thing we know is a market already is the bike market. And I looked at making bike stuff as well, like hand grips and stuff like this. And I just thought the pricing was crazy. And this is another example of this. These are Lure shoes. There was a Lure 1 shoe a while back, and now they made the Lure 2. These are shoes that are custom made, and hold on for this. They cost between about $1,300 to $2,000, like $2,000 for a pair of shoes. That to me is, that's quite pricey. What is worth thinking about is that initially the Lure 1, they had an iPhone app and you could just scan at home your own feet. Right? And now they're making you go to like a approved dealer of their products to make them do the scan. So, that's something we should think about. Like, can we get everyone to scan everything at home? Or maybe that doesn't work so well. We all expect the newer versions of iPhone to 3D scan better, especially because we're getting more cameras and they're doing stuff with this time of flight technology and things like that. But maybe that isn't happening. Maybe it's still better to get a kind of like a Einscan type 3D scanner at a specific facility with a person who has training doing that. I found that was interesting. Now, what their whole pitch is that this thing can look at bone spurs and Morton's toe, whatever that is, different size and shape feet and all that kind of thing. And you can get a really good scan, and then they will customize a shoe. Now, they do a carbon airframe, which is made by their own kind of like carbon fiber type technology, not a 3D printing technology necessarily. That creates kind of an exoskeleton. Then there's footbeds, and then there's 3D printed kind of pad type of things that customize it. Now, what they also have on the Lure 2 is they've got a 3D printed cuff. Now, the idea of this cuff is that when you raise up your foot, right? So you're pedaling, you go down, and then when you raise back up that foot, right? Then that cuff is supposed to help you do that and create more power while doing that. I don't know if this is true. The company says that this could increase something called pedal drive, which I'm not sure what it is, wattage, which I kind of know what it is, and metabolic efficiency, which I thought was something completely different. Now, if those three things could be increased, perhaps you could be faster, and perhaps you could then, on the upstroke, if you will, return the pedal faster or even maybe accelerate even quicker, which could be handy in certain cases as well. So that 3D printed shell, that's kind of a new thing. We haven't had that many people really think too much about what these type of shell kind of structures could do for us. But perhaps it can make you climb faster. Well, we'll see if this works in the year. I think it's frightfully expensive. But hey, this could be a new market. I really believe in custom shoes for athletic pursuits and really customized experiences for, whatever people find important. So, yeah, this is something worth watching. My name is Joris Peels. This is brought to you by 3D